Morning everyone. In the first unit in Markowitz model, so we are dealing with the problems here. So already I have completed two of the problems in Markowitz model. So let's look into the problems in Markowitz model. Here the problem given is stocks of X and Y have yielded the following returns for the past 6 years. So you are given with the information of number of years and return of stock X and return of stock Y for the past 6 years. What is the expected return and risk of a portfolio made up of 60% of X and 40% of Y? So you have to find out the expected return and risk of a portfolio. If it is made up of 60% of X portfolio and 40% of Y portfolio. Coming to the solution of the problem. So calculation of expected rate of return and risk on individual security. Here we have two securities X and Y for 6 years. For the past 6 years information is given. So here you have to find out the X bar. X bar is nothing but summation of X bar is equals to summation of X by N. X here I'll take I because individual securities. We are given with information about individual securities. So summation Xi by N, that is equals to, so summation individual securities, what is the total of returns of X, that is 12 plus 18 plus 14 plus 22 plus 15 plus 20. You have to add those individual securities and upon n number of securities. We have to divide it with n number of securities. So total it comes to 101 upon 6. So here you are going to get it as 16.83%. Okay. So this is X bar. X bar is nothing but summation X by N. So summation X means you have to add all these individual securities upon n number of securities. For how many years you have? It is for 6 years. So 6. That is 16.83%. So here in Markowitz model, you have to find out the standard deviation as well as variance. So for that purpose, we are going to take it as X minus X bar. So X minus X bar and X minus X bar the whole square. So here what is X is return of individual securities. So 12 minus X bar we have already find out, that is 16.83. So each and every individual security has to be subtracted with the X bar, that is 12 minus 16.83. You'll get the values here. So same way you have to do it for other years also, that is 18 minus 16.83, 14 minus 16.83. So all these if you subtract, then you are going to get these values. Then X minus X bar the whole square. So X minus X bar the whole square, whatever value you have got here, that is minus 4.83, that should be squared. So minus 4.83 the whole square, 1.17 the whole square, minus 2.83 the whole square. I have written it separately. So here you make a note of all the things and calculate and write it separately. then it will be clear for you. Then it is very simple also, not that much difficult calculations. So one is the information given years and returns, and then we are going to find out x minus x bar and x minus x bar the whole square. So this is to have the to substitute the values for Markowitz model formula. Okay, we are finding these values. So here I have written it separately, that is x bar is equals to, already I have explained this to you in the previous slide, that is summation x by n. So summation x by n here, as it is for individual securities, I is specified, that's all. So I means individual securities. Different securities are given now for the past 6 years. Those securities will be taken into account. That is 12 plus 18 plus 14 plus 22 plus 15 plus 20 upon 6. N is 6. So 101 upon 6, that is equals to 16.83%. This already we have seen in the previous slide. So here we have to find out the variance. So variance, what is the formula for variance? It is summation of x minus x bar the whole square upon n minus 1. So that's what we have done in the previous slide. X minus x bar we have find out, and based on that we have whatever values we got, we have squared it. So we got it as 72.8378 upon 6 minus 1. So variance formula you have to keep in mind, and then you have to substitute the values. So once you have found out the variance, then standard deviation is easy. Standard deviation is nothing but root of variance. So variance value is 14.57. So just keep it as under root. So under root 14.57 under root is 3.817. So next, the same procedure you have to do for returns on y. So x part we have completed, that is calculation of variance and standard deviation for security x we have done. The same way you have to do it for y. So again write the years and return on y. So here also we are finding the y minus y bar and y minus y bar the whole square for calculating the variance and standard deviation. So y bar, before doing the calculations, you have to find out the y bar. It's very simple, that it is summation y by n. So summation y means individual securities are given. So take 22 plus 18 plus 14 plus 10 plus 12 plus 18 upon total number of securities or 6. So summation, if you do it the total, you are going to get it as 94 upon 6. That comes to 15.67. So now easily you can substitute it here. That is y minus y bar. Y means written on single security 22 minus 15.67, that comes to 6.33. Again 18 minus 15.67, that comes to 2.33. 14 minus 15.67, that comes to minus 1.67. So once you have done this calculations, then go for y minus y bar the whole square. So square it, 6.33 into 6.33. So you are going to get 40.07. 2.33 into 2.33, that comes 5.43. Same you have to do it for other numbers also. So now total it, 99.34 you are getting up. So here we are going to find out the variance and standard deviation. So variance is equals to 99.34 upon 6 minus 1. So by doing the calculation, you are going to get it as 19.868. This is variance. So standard deviation is nothing but it is square root of variance. So that is 19.868 under root. So that will become 4.46. Then finding the covariance of xy, the formula is summation x minus x bar into y minus y bar upon n minus 1. So already we have taken the values of x minus x bar and y minus y bar. By substituting the values here, we are going to get for different securities, we are going to get these values and the total will become minus 38.3334. So substitute the under the equation, that is covariance of xy is equals to what all the individual securities what you have done, that total minus 38.3334 upon n minus 1, that is 6 minus 1, that is 5. That though that the value will become minus 7.67. So this is covariance. And now we have to substitute it in the Markowitz formula, that is return and risk we have to find out. So here expected return of portfolio formula is summation of x bar x into r bar x, x bar y into r y. So here as it is given in the question that it is 60% and 60% of x and 40% of y. So you have to find out the risk and return based on the 60% of return of x and 40% of return on y. So substitute the values here. 60% means it is 60 by 100, that is 0.6 into Rx what we have found out, that is 16.83. Then x bar y, that is 40% means 0.4 into Ry, that is 15.67. So by doing this calculation, we are going to get it as 16.366. This is expected return on portfolio. Then standard deviation, that is risk formula, as already I have explained the formula. You have to take the covariance of two securities. So that's why we are taking it under root, and the formula is square root of x square into standard deviation x square plus y square standard deviation y square plus 2x 2 into x xy, two securities x and xy, then standard deviation x standard deviation y into r xy, that is coefficient of correlation, that is covariance of two securities. So that will become, here just the thing is you have to write down the formula, then substitute the values. So it is x square, it is 0.6 the whole square, that is 60% of x stock, and the standard deviation we have found out, that is 3.817, make it whole square, plus y square, that is 0.4 whole square into standard deviation y square, that is 4.46 whole square, plus 2 into x, that is 0.6, y, that is 0.4, 40%, into standard deviation x into standard deviation y r xy, that is the covariance minus 7.67. So here directly we are taking covariance. So if you take, I'll explain here. So Rxy, that is coefficient of correlation, is equals to covariance of xy upon standard deviation x, standard deviation y. So as already we have found out the covariance of xy, that is equals to rxy. If you cross multiply rxy into standard deviation x into standard deviation y. So this whole value covariance we found out that has come to minus 7.67. So directly we are writing the value here, minus 7.67. So here, if you calculate these values, you are going to get it as it is in minus. So plus into minus, here you will get minus. So standard deviation P, that is the risk of a portfolio, is equals to root of 4.746. That comes to 2.178. So this is about the portfolio return as well as portfolio risk of the two stocks, X and Y.